Hi, and welcome to the video on balancing the combustion of butane. So my first step, I'm going to do a tally of all of my atoms here. Carbon, I have 4 carbons on the reactant side. For hydrogen, I have 10. And for my oxygen, I have 2. Do the same thing on the product side. Carbon, I have 1. Hydrogen, I have 2. And for oxygen, since they're in 2 separate molecules, I have to be careful. So I have 2 plus 1, which gives me 3. Okay, now what I'm going to do is I'm going to start changing the coefficients of my elements, so that of my molecules, so that I can get the same number of atoms on both sides. And I'm going to, of course, balance the oxygens last. All right, so starting with carbon, I have 4 carbons on the reactant side, 1 on the product side. I'm going to give CO2 a coefficient of 4, so that way I have the same number of carbons. Of course, once I've done that, I've changed the number of oxygens as well. So I'm going to retally my oxygens. 4 times 2, which is 8, plus 1 gives me 9. I have now 9 oxygens here. So I'll do that again. 4 times 2 is 8 oxygens, plus the 1 from the H2O, that's 9. Okay, now we can go on to balance our hydrogens. I have 10 on the reactant side, so 10, and then 2 on the product side. So I'm asking myself 2 times what will give me 10, and that would be 5. So I have to change the coefficient here to a 5. That again changes my hydrogens, of course. So they're looking good, they're balanced. But also I need to change my oxygen. So again, I'll retally. I'm not going to just add 5. I'm going to retally everything. 4 times 2 is 8, plus 5 times the 1, which is 5, right? So 4 times 2, 8, plus 5 gives me a total of 13. So I have 13 oxygens. Okay, now the last step is to balance my oxygens. So I go to the reactant side. I have 2 on the reactant side and 13 on the product side. So now I'm asking myself, well, 2 times what will give me 13? And the value I get for that is 6.5. So I go ahead and put a 6.5 here, and that will balance out my oxygens. Okay, but remember the last key strategy. We cannot have a decimal as a coefficient for the balanced equation. Our coefficients must all be whole numbers, and that's because if you're reading this as molecules, you can't have 6.5 oxygen molecules. All right, so what we're going to do is we are now going to change the coefficients, and remember there's an invisible 1 here, invisible 1 coefficient, okay? We're going to change the coefficients, and we'll do that by multiplying the 6.5 by 2, which is the smallest number I can multiply 6.5 by to make it a whole number. All right? So just like in math, whatever you do to one side, you have to do to both sides and all the terms on both sides. So I'm going to have to multiply the coefficient in front of butane by 2, the coefficient in front of CO2 by 2, the coefficient in front of H2O by 2. So I got to multiply all those. And that gives me, at last, my final balanced chemical equation here would be 2 c4h10 plus 13 O2 goes to form 4 times 2, which is 8 CO2 plus 5 times 2, 10 H2O. This is the final balanced chemical equation. All right, I hope you found that video helpful. Have a quality day.